So today we're going to practice writing the equation for a quadratic using 3 points on the graph, which we've now done for several days. But what you're going to have to do this time, the extra step, is going to be to read a word problem and create your own picture for the situation, and then you will identify the critical points you need to write the equation. So that's the new part. So they're going to be problems similar to this one. The problem talks about a boy that throws the plane to see how far it's going to go, and they give you the maximum height of 5.35 feet after traveling 15 feet horizontally. So what you would do first is part A says to sketch a picture, and what you're going to have to make sure that you do is you're going to have to make sure that you scale and label both axes. Okay, so it's really just a rough sketch. You're not plotting many actual points, but for example it says that the plane went to this maximum height after traveling that far horizontally. So that means that they've given you the vertex, and that vertex, the plane traveled 15 feet horizontally, after which it reached the maximum height of 5.35 feet. And then it says that he released the plane from a height of 4 feet above the ground. So before the plane had traveled anywhere horizontally, it was 4 feet above the ground. So it was maybe somewhere right around there. So it hadn't traveled anywhere horizontally yet, but it was 4 feet above the ground. And so that means the plane left his hand, went up to the vertex, and then comes back down, we assume, all the way to the ground. Okay? And it hits the ground, and obviously it doesn't go below the ground. And so if you have read the situation, then you also understand that this horizontal axis is your horizontal distance that the plane has gone, and everything is being measured in feet. And then this is the vertical height or distance, however you want to equate that, and that's also in feet. And that's all you need to do. You don't have to scale every 1, 2, 3, 4 because you don't know most of that information. Okay, so we've actually got a sketch of the situation. So then part B says to write the quadratic equation for that situation. Well, given the information that we have, we know that what we're going to write is going to be vertex form. So once again, just a reminder, your vertex form is that. Okay, and we know the vertex, so of course step 1 would be to plug in the vertex. So we plug in the 15 feet horizontally and the 5.35 feet vertically. And obviously with a decimal in the problem, you know you're going to be working with decimals, so you will want a calculator for many of these problems. Okay, and then we take the other point that we know on the graph, which was the height that the plane was released from, and we plug it in. So I'm going to plug a 4 in for the y, plug 0 in for the x, and then we can solve for our a value. So I'm going to subtract the 5.35, so that gives me negative 1.35. It's equal to a, and then this part right here is negative 15, and then it's going to get squared, which of course gives me 225. And then I divide. Over 225. Okay. Now, At this point, what I would suggest that you do is you go ahead and you plug it in your calculator. We don't typically mix decimals and fractions. We do want A to be a fraction most of the time, because most of the time, not all the time, but most of the time it would require rounding or truncating if it were a decimal. So we want your calculator to convert it to the most reduced fraction that doesn't have any decimals still contained in it. So if you take this fraction, type it into your calculator, have it convert it to a fraction, it's not going to do one with decimals. It's going to give you what they consider the neatest fraction, which is -3/500. Okay, and so we now have our equation finished. So our equation is y equals -3/500 x minus 15 squared plus 5.35. Okay, so that's part B. Okay, and so now we get to use that equation to determine other information. So when we get to part C, it says, what is the distance the plane traveled? Well, remember, the plane started here, goes up, and then comes back down to the ground. Like I said, the situation didn't tell us any differently, so it's not like somebody caught the plane, because the problem would have had to tell us that. And so that means we know it's going to come down to a height of 0. And so what we're being asked is, we're being asked, how far horizontally did it travel before it gets back down to the ground at 0? Okay? And so we want you to show the work and the setup of rearranging and stuff, but ultimately you will have to have a calculator for this. Excuse me. So when I take my equation and set it equal to 0, then you show the work of doing the rearranging, and you use a calculator for many of the steps. And then what you figure out is, if you take the time and rearrange it and solve it, you solve for x. Now, part of the process of solving is going to involve square rooting. So I do want to run through that real quick, because there's one thing that you need to keep in mind with these real-world problems. So I'm just going to, I don't want to have to flip pages back and forth, so I'm just going to erase this up here. And I'm going to come up here and do the rearranging to solve it initially. So I'm going to take this 5.35 and I'm going to subtract it to move it over. So negative, that's not dark enough. Negative 5.35 is equal to -3/500 x minus 15 squared. And then the next step would be to take the fraction, -3/500, right there, and divide to move it to the other side. Okay, and so when you do -5.35 divided by -3 divided by 500, you end up with 891.6 repeating. And so we could write that as a fraction. I mean, we could, but we know we're going to get decimal answers, because that's what makes sense in the real world. And really, that's not the reason I wanted to show at least the first few steps. The reason I wanted to do that is because my next step is going to be to square root both sides to get rid of this squared right here. So square rooting it will get rid of the squared and leave the x minus 15. Now, what you guys were taught in Algebra 1 is that when you square root to solve, you need to do plus or minus. And you can do that initially, and sometimes you'll include both answers, but we're only looking for the positive answer right there, because the plane didn't travel backwards horizontally, it only traveled forwards horizontally. So in this one instance, okay, you don't really need to even consider the negative answer. If you want to go ahead and find it, you can, but you're not going to end up using it anyway. And then, of course, your last step would be to take the 15 and add it to move it over. And so you have your positive 15. And so then you're going to need a calculator to finish that problem anyway. And so you would have 15 plus that square root, and you would get 44.861. So I'm kind of out of room, but our solution is x equals 44.861 feet. And that is how far the plane traveled horizontally before it came back to right there and landed on the ground. Okay? And then the final part of the problem, once again I'm going to need some room here. Okay? So the final part of the problem says, for what distance is the plane's height greater than 5 feet? And so you want to know if we were able to draw a horizontal line across the graph at y equals 5. What we're doing is we're essentially marking the two spots where the plane actually is 5 feet off the ground, and what it says is, for what distance is the plane greater than 5 feet? So we want to know, where is the plane above that horizontal line? So you have two options. If you're asked to do it algebraically, you would repeat what we did right here, but instead of setting it equal to 0, you would set it equal to 5. And what that would let you solve for is it would let you solve for the x values right here and right here that told you the two times when the plane was at 5 feet high. And we know that in between those two times the plane is above 5 feet high. But the more common thing for us to ask you to do would be to have your calculator graph this equation. So you put this equation right here, your quadratic, in for function 1. And then you would do function 2 is just your horizontal line at 5. And then you would have your calculator solve for the points of intersection. Okay, and when you have your calculator solve for the points of intersection, what you figure out is you figure out that in between 7.362 and 22.638 feet is where the plane is above 5 feet in the air. So you would write it as x is in between 7.362 and 22.638. Okay, so that's how you're going to do a lot of these problems. The worksheet that you're going to be working on these application problems is not due till Monday, because I'll be back tomorrow to obviously do one new thing as well, but to check some answers, do some question and answer, help you guys get caught up. Okay, see you guys tomorrow.